Okay, we will continue the second part of the bioavailability and bioequivalence part, in which um, we will talk about the first pass effect. We all know the first pass effect, and we all know that it's something very important to take into consideration when we are talking about extravascular routes of administration, right? What can we use on from the whatever that we know from bioavailability to determine the first pass effect? Can we determine if there is any evidence of first pass effect? One of the ways to determine if we have first pass effect when the absolute bioavailability using the methods that we used already is less than 1, which means that this is one factor that could affect, but it may we may have other reasons for sure that is related um, to the physiological factors or formulation factors. But one of the reasons, if the first pass effect is there, the absolute bioavailability will be less than 1. Okay, how we will determine this or what we know about this? Let's consider that we are talking about oral extravascular. So we have the lumen here, we have the cells of the gastric cells or the GI cells in the wall, we have the portal vein, and then we have the liver. But portal vein will carry the blood to the liver, in which mainly the portal vein will carry the blood to the liver, and then we have the systemic circulation. We have metabolism either in the liver, either in the cells, or even in the lumen, and we have excretion to feces here, and we have also excretion to the bile salt here. So this is a diagram that simplifies the overall pathway of the drug that goes from here to this location, which consider the drug or the definition of bioavailability of the drug, because we said it's the rate and extent of the drug reaching the systemic circulation, which is here. Okay, so whatever is happening to the drug before this point, before reaching this point, we are talking about first pass effect. Usually the definition of first pass effect, considering which is the definition that you know in your other courses, they usually consider it just the metabolism in the liver or whatever that is happening in the liver as metabolism. And this is not true. It's everything that is happening to the drug before reaching the systemic circulation, but majorly it's related to whatever to whatever that is happening to the drug and the liver as hepatic metabolism if it goes under metabolism. So if we talk about again oral extravascular, and we will talk about sequential factors. We have this one, which is the fraction of the drug that survives whatever is happening in the gut lumen, either metabolism or excretion in the feces. Then we have fraction of this fraction that is surviving the metabolism that is happening in the wall. Then we have fraction of this fraction that is surviving whatever is happening as metabolism and excretion and the bile. Um, then if I want to determine whatever is happening to the drug here, the fraction of the drug reaching the systemic circulation, or capital F, it will be the multiplication of all those fractions. The fraction, I don't care that much about the symbols of each one of them because it's different according to the reference that you are using. But we have either the fraction that is successfully passed through the gut. This is the first one. We have this that is successfully from the gut into the portal vein, which is the second one, and then the hepatic, which is directly to the systemic circulation and survive the first pass effect of the liver. So the issue of this a way of determining the fraction that's reaching the systemic circulation, which is the one that we are talking about here. It's a sequential fraction. This fraction is a fraction of this, and this fraction is a fraction of this, and this is a fraction of whatever was here. Okay? I will talk a bit in Arabic just to make sure that you got it right. بالعربي هلا أنا أخذت إشي هون right اللي هو الأورال. طبعا في عنا إحنا قلنا إنه أنا في عندي at the beginning الدوز right. هلا في عندي إشي ال XGI right. ال XGI في عندي ال initial at the site of absorption and all of those kind of details حكينا عنهم قبل. هلا الفكرة أنا عم بحكي شو عم بيصير للدرج قبل ما يوصل لهاي النقطة. هلا في أكثر من طريقة ينحسب إنه أنا شو عم بيصير قبل ما الدرج يوصل هون. واحدة من الأشياء again it's not easy to do it experimentally بس واحدة من الأشياء إنه أنا بقدر أعرف شو بيصير هون للدرج وشو بيصير هون. again في عندي metabolism وعندي excretion before I pass this membrane. هلا تنسوش إنه أنا كنت دائما أعتبر إنه أنا عندي membrane، أنا بيكون في عندي XGI هون، بيصير في عندي absorption هون، بروح على طول جوا البادي. It's not as easy as this. هلا أنا دائما كنت أعتبر إنه أنا هذا الممبرين اللي هو هذا إنه خلاص I pass it I'm fine. ما كنت أعتبر إنه في عندي لا metabolism ولا excretion. ما بحكي عن fractions. أوكي كنا نعتبر إنه أنا خلاص في عندي one compartment and whatever is happening is under K. Okay, so the details of it إنه أنا في عندي جزء رح يصير له metabolism و excretion before I reach that membrane. فأنا fraction من اللي موجود هون رح يطلع. أنا في عندي fraction هون، fraction من اللي موجود اللي فات هون رح كمان يقدر يطلع من الوول لأنه جزء بيصير له metabolism. هلا هذا الفراكشن رح يفوت جوا الليفر. تذكروا الكليرنس الفسيولوجيكال definition of the clearance إنه أنا في عندي N وفي عندي out وفي عندي extraction. نفس الفكرة إنه أنا عندي الليفر هون جزء من اللي عم بفوت عم بطلع، مش كله عم بطلع، لأنه أنا يا إما عندي metabolism بالإنزيمز اللي بالليفر أو excretion بالبايل duct. Okay, so whatever is reaching here لأنهم sequential fraction رح يكون this fraction multiplied to this and multiplied to this. Okay, so it depends on the way or whatever that data that you have or available for you to deal with. If you have sequential fractions, so you'll use the sequential fractions as multiplication of all of them. For sure, if you have, let's say, if we are talking about, I gave you a whatever is metabolized here as a fraction of metabolism here, right? And I give you the fraction or extraction, right, of metabolism and excretion here اللي هي نفسها, it's the same as the extraction ratio through the liver, right? So the extraction bear place أو extraction here. So إذا أعطيتك extraction or the fraction of metabolism or excretion, this will be what? 1 minus whatever is happening here. And this will be 1 minus the fraction of or extraction that is happening in the wall. And this will be 1 minus whatever is the extraction is happening in the hepatic. So شو اللي عم بحكيه هون؟ It depends on خلينا ننظف الرسمة. It depends على أنا شو عم بعطيك. إذا أعطيتك fraction of absorbed fraction again بديش أحكي samples. Fraction survived here, fraction survived here, and a fraction survived here, right? So these are sequential fraction. عم بحكي عن the fraction of the drug that is passed through each and every step. يعني أنا في عندي step هون هي 1، عندي step هون هي 2، and عندي step هون اللي هي الليفر. هدول the fractions that survives المقاسي اللي بتصير بكل واحدة منهم بغض النظر كانت metabolism, excretion, whatsoever. I don't care. Okay, so it survives each and every step. If you have those kind of fraction, the total fraction of the drug reaching the systemic circulation will be the multiplication of those sequential fractions. If I give you data related to whatever the fraction or the extraction that is happening at each part of it, let's say this is extraction of absorption, This is extraction. If we use the same symbols, this is extraction of the gut, and here extraction of the hepatic. Or I gave you this with this and this. You need to, if you have this, it will be the fraction of absorption will be minus the extraction and the absorption. This will be 1 minus the extraction in the gut, and this will be 1 minus extraction in the hepatic. Okay? This is the way to deal with. So because it's sequential, again, I use multiplication in each and every, between each and every one of them. So that's why we are using multiplication between them, because it's a sequential fraction. Yani fraction of fraction of fraction. That's why. But usually, we don't have this kind of privilege to determine the sequential fraction. What we have usually, that we know, as we said before, in the physiological clearance, for example, that I know that this is the liver, and I know that this is the extraction ratio of the liver, as we know earlier how to do it, which is equal concentration N minus concentration out over concentration N. I know this, and if I have some details about any non-hepatic fraction of metabolism, the fraction, total fraction reaching systemic circulation will be 1, which is everything, minus whatever is happening in the extraction in the liver, minus anything else happening elsewhere. Again, what we are measuring here and what we are measuring even here, it's the absolute bioavailability of the drug, because the definition of it, it's the fraction of the drug that is eventually reaching systemic circulation. So it's bioavailability, but it's the absolute bioavailability of the drug. Okay? So usually what we have, the extraction ratio or the fraction of non-hepatic is usually negligible. So if it's usually, as the usual case, this is not there, so the total fraction of the drug reaching the systemic circulation will be 1 minus extraction ratio, because we are talking about fraction, and we are talking about fraction happening in the hepatic. And this is by common sense, okay? But why we are interested in this as way of calculating absolute bioavailability, if I'm able to do it using area under the curve. The idea is, if you remember when we talked about the extraction ratio, this is very hard to measure as extraction ratio, because you need extraction inside the organ, you need a concentration, sorry, that is getting in the organ, concentration getting out of the organ, and do some measurement here to determine whatever is happening here. So it's not that easy. So what we usually do the measurement of the absolute bioavailability using the plasma or urine data to determine the absolute bioavailability, and from that we can determine the extraction ratio of the drug. So the whole thing here, even it's true to determine the absolute bioavailability from the extraction ratio of the drug in the hepatic, but usually it's used to determine the extraction ratio, not the opposite. يعني أنا عم بستخدم الابسولوت bioavailability بالطريقة اللي إحنا حسبناها، أو بالطرق اللي إحنا عرفنا كيف نحسبها عشان أحسب الاكستراكشن ريشيو للدرج، لأنه it's not easy for me to experimentally determine it. About this, the liver extraction ratio, this is the thing that we talked about before, and I just keep talking about it when we were using this, or and here, this part. So it's similar to whatever that you know in the clearance chapter, in which we talked about it as a physiological definition of the clearance. The only difference here, that rather than organ X, we are talking about hepatic, and similar definitions and similar way of dealing with it. Okay? This is a side note of whatever you know already about extravascular and IV bolus. If you remember, when we were talking about um, when we were talking about the IV bolus, This is the, for one compartment single dose, this is our function model equation, or this is our function of the profile that we have, that we were using it, CP versus time, to determine what. This is the profile. So we were doing 0 to infinity integration, right? 0 to infinity integration to determine area under the curve. And when we did this integration at the end of this function, we had area under the curve that is equal to concentration, initial concentration over K. Or in another way, X naught over clearance, right? Or X naught over K multiplied to VD. This is the CB naught, right? So CB naught over K, or X naught over clearance. It's the same. If we take this for IV bolus, as we know, okay, and then we continue with whatever that we know for extravascular, when we do the integration of the function that we have in the extravascular, which is our model equation, by exponential model equation for extravascular route of administration, one compartment. When we do the integration of the function, we will have the same thing, but the only difference that we are having, in addition to X naught over the clearance, we will have fraction of the drug, and which is this one, okay? And we keep talking about it as fraction of the drug reaching the systemic circulation, or the bioavailability, right? When we compare this to that, we have here area under the curve, total area under the curve for IV bolus. We have here area under the curve from 0 to infinity for extravascular route. If we have the same dose here and there, we are having the same dose, and I'm comparing or dividing area under the curve total for extravascular over that for IV bolus. What you will have? What is the result of this? So we are having area under the curve for the same dose, 0 to infinity, for extravascular, let's say route of administration 1, over area under the curve, 0 to infinity for IV bolus. This is what I'm asking you to have or to calculate. According to whatever that I just mentioned, it will be equal to F, okay? And F, it's the same that we had before in the equation of extravascular, which means that F that we have here is the absolute bioavailability of the drug, because it's equal area under the curve of the first extravascular or the first route of administration over IV bolus. Again, this is if we are talking about equal doses for the same dose, equal doses for the extravascular and area of IV bolus. So the bottom line or the take-home message from this, we know how to calculate area under the curve for IV bolus, and we know how to calculate area under the curve total for extravascular. And the idea is, if you have the ratio of both of them, you will have the result as F, which is what you know as absolute bioavailability. So F that you have in the equation of extravascular is your bioavailability, and it's absolute bioavailability because it's what you have when you have it in reference to IV bolus. You'll have this question to practice. The idea of the question of bioavailability and bioequivalence إن شاء الله إذا ربنا ييسر بعد السحابة اللي إحنا عايشين فيها، وإن شاء الله إنها رح تمرق على خير. The idea of the questions of IV bolus or even extravascular route of administration bioavailability and extravascular bioavailability and bioequivalence, excuse me, it's that either it's conceptual questions, which is related to the definition of whatever we said in the beginning of this chapter, or it's calculation. The calculation, it's super duper easy, but the idea is you need to make sure, if I'm talking about or asking you about plasma, using plasma data, or using urine data. For example, the absolute bioavailability of formulation 1, so I'm talking about formulation 1, I'm talking about absolute bioavailability, so I need to compare it with IV, but as I'm talking about uh, plasma data, so I need to use area under the curve. So whatever I need to use is this and this, using those kind of doses. So the main problem with the substitution with when students substitute numbers or using numbers in the exam, they use the wrong numbers. That's why it's an easy question, but because they substitute the wrong numbers, this is what happens. And the second one, we need relative for formulation 2 using urine data. So I need the relative for second formulation. So using urine data, so I need to use this with this dose, but it didn't tell me relative bioavailability to what. But by default, as I have one on the oral uh, other formulation and IV, it won't be this for sure, because otherwise it won't be a relative, it will be absolute. So I need to use this, which is the other extravascular with its dose. So let's use other color. So for this question, you will use those. For this question, as it's plasma data, you will use this with this. Okay? Another point that is usually you need, if you have urine data, to make sure that we are talking about enough time for the drug to be excreted in the urine. But as you noticed in this question, I didn't give you the half-life of the drug, okay? So if I didn't give you the half-life of the drug, just go with the calculation and do it, unless I give you that there is no enough information to calculate. But if I gave you the half-life, you need to make sure that you passed 5 half-lives at least, so you can use urine data. Otherwise, we can't use this if we didn't pass 5 half-lives.